All right, so next word we're going to talk about here is proportion, which is a word that you have probably already seen in sixth grade. And so we're going to kind of keep building on our understanding of it like we've been doing. So I'm going to just press the little magnifying to zoom a little bit here since we're just going to do this page today so you can see better. And then I'll press the arrow so it stops zooming. So the definition for proportion would be a statement two ratios are equal. Okay. So we're kind of writing something out. We're saying that the two are equal. So you can go ahead and enter once or twice, and then you have a definition in your words. So try it out, see what you got. Okay. So characteristics of this. The big thing that we kind of want to know with proportion is that when simplified, each ratio should have the same unit rate. So that's one way that I can check that things are proportional, that they all have the same unit rate. Okay. So examples of this, we said that a proportion is just when it's a statement that two ratios are equal. So we could have something like 1 to 2 equals 2 to 4 equals 3 to 6 equals 4 to 8, and so on and so on and so on and so on. I can see that those are the same because of the same ideas we've been talking about. 1 to get to 2 is times 2, and 2 to get to 4 is times 2. So we're multiplying the same numbers. Or you could go the opposite direction and say 4 to get to 1 is divided by 4, and 8 to get to 2 is divided by 4. So that's one way to check. The other way that we wrote up here is just seeing that they have the same unit rate. So if I do 1 divided by 2 in my calculator, it equals 0.5. And if I do 2 divided by 4, it equals 0.5. And if I do 3 divided by 6, it equals 0.5. And if I do 4 divided by 8, it equals 0.5. So that's another way that I could check that these are actually ratios that are equal or equivalent ratios. So non-examples would be kind of the same stuff that we've been talking about. So something like 1 to 2 equals 2 to 1. That's not true because we know we can't flip the numbers around. It means something different. Since divide is not an operation that we can move operations around, and really ratio is comparing two quantities by division. That goes back to what that ratio definition is. Another good example of a non-example of this word would be something like 1 to 3 equals 3 to 4. They actually don't equal those things there. So even though we may have added some similar things to our numbers here, they don't multiply or divide out correctly. And that's going to be what we're really looking for here. So we could add here that this is not true. And then this one is also not true. And that's your idea with proportions.